Let's talk about porting 372 a little bit. What I'm looking for, what I'm playing with, what I'm measuring, what makes a good saw to work with, and what makes a not so good saw to work with, maybe. Um, every saw out there's got a bottleneck somewhere in the system. Finding that bottleneck is the first place you got to start, generally. So we talk about different designs, and one thing Husky has going for it is that the boot is straight. It's the same size on one end as it is the other. Steel boots, small at the carburetor, large at the cylinder. It's tapered. The straight intake is better. It keeps the velocity up. I see a lot of guys, I watch videos and I end up laughing a lot of times, but what really gets me lately is these guys grinding these tonsils into the intake. We'll make that a great biggest hole we can possibly make it, right? Kind of make the port look like that. Is that big hole on that end going to make this flow any better? If you're porting a saw, you're building a work saw, and you're going with stock parts, you can modify this carburetor some, make it flow better, right? You're limited to what you can do on it for flow, but you can make it flow better. The only thing that's going to improve this intake port to get more fuel in that motor is to add more duration to the port. Making the hole wider, taller, bigger doesn't make anything flow better. If anything, it's going to make it flow slower, because as the air is coming in, it's getting bigger and bigger and bigger, and it's just slowing down. So if anything, you're probably losing performance by raising or widening a port, an intake port. The floor is what changes your timing. And I've gone over this before about measuring like the surface area of this port to the surface area of this boot or the carburetor. And if we get into some real terminology, we start talking about port time area and mean port time area. The first half, this port's open in degrees. Let's say we got 160 degree intake. The first 80 degrees does 90% of the flow of that intake. Everything up above that doesn't do much of anything. Right? So raising all of that port literally does little if anything, or makes matters worse. So I don't for a work saw, I will never widen a port. I might clean the edges up, but I'm not trying to widen that port. I'm not trying to raise the port. I'm just concerned about my timing. And many of my saws, you'll see that I actually put epoxy on the roof and lower the roof. If I take 5 degrees out of the intake on the floor and increase my duration 5 degrees to keep that port the same size as the factory, I would lower my roof 5 degrees. If that makes sense to you. I have to work with what's given to me. So if you're afraid of the epoxy, just lower the floor and don't do anything else. You're all right. If you want to increase that performance many times, lowering the roof will increase your performance. Unlike the theory everybody else has is the bigger the hole, the better. It's not always the case. So where's our next restriction? Well, we have to start looking at the lower transfers. And on these saws, that's where the big restriction is. A lot of the 3 Series Huskies. You got this flange down here. It goes all the way across the transfers. If you look at the transfers, you know, you got a relatively big hole here. If you look down inside, which I'm not going to be able to do without a shadow, but the transfers in here are by far smaller than they are here. That's an obvious restriction. But there's another restriction that a lot of guys miss. And that's in here. So I made this little blue line kind of around the circle here, right? Of where that flange is at. And the flange doesn't touch here, but it's in there. And it's very close to where this radius is here. And this is all restricted because of how far the flange comes down into that. So let's measure that. You can simply measure that right here on the flange, right? 280 thousandths. Let's measure this. Here, a rough idea here. $570. Right? So that port from this flange to that base, you know, in rough terms here is 300 thousandths. Right? 280, that's almost 300, almost closer to 200,000, saying it's not a lot. You guys can do the math. So this is all restricted in this area on almost all 3 Series Huskies. Right? So everybody and their brother, they grind this all out. This flange in here. They grind way down in here and they put a great big old hole in there. However, the piston still drops down to about in that area of that flange. Right? So grinding a whole lot out of here, big old hog like way up there, doesn't make much sense because now the piston is going to set down in that hole and block that. Right? So grinding some off the flange, off the sides of the flange here, helps. But we can go further by taking some of this out so we can take that even further. We can further improve that if we want to split these cases. This is a bearing pocket, but you can take some off of here on an angle, and you can fill a little back in this back corner, and you can open this up and you can get this to flow better. Little epoxy in there and a little grinding in there, and you can free this up. You can't take a whole lot because it is a bearing pocket, but you can take some out of there. Both sides, of course. I don't do this work unless I have the case apart for some reason. I don't split the cases to do it, but I'll do some of that if I have the case split. I also will bolt the cylinder on one half of the case, and I will port match this to this if I have the cases apart. Makes that a smoother transition. So then, now we got this opened up, but the transfer port down here is still quite small. And them are my numbers as we speak. This isn't adjusted to the height that I want it yet, but that gives you an approximate idea of what I'm going to be taking out of there when I get there. I've only got, 100 degrees of transfer opening up there, and you can see how far that is, and that's probably, I'll be taking half of that distance out of there. I didn't degree this yet to see my block is at, but that doesn't give me any blowdown where it's at right now, so I'll be changing that some. But in any case, now I have to pay attention, because if I take and measure this, here, my block, or where my transfer opening is going to be, or where I think my transfer opening is going to be, kind of sight that across. I can't open my transfer up to that, right? I'd be grinding through. Kind of where I'd like to be, but, it won't be that high, but you get the idea of what I'm doing. I've got to keep this in mind, that I can't grind through. So that's got to be thought out in play, and I'll have to degree my block and everything here, but which I haven't done yet because I'm not to that point in my work. I start with the intake. I know what I want for duration. I'll decide if I'm going to put something on the roof. This port appears large. I probably will. We get over to the exhaust port. We got to raise that exhaust port to get a whole lot of RPM, right? Why does raising the exhaust port increase RPM? 99% of people out there will get it wrong. The only reason that it increases your RPM is because you've decreased your compression. A freer running motor will turn more RPM. So if you reduce the compression, it runs freer, it will turn a higher RPM. It's the only reason. Your RPM gains are in your intake and transfer, not in your exhaust. You only need enough exhaust to get the exhaust that's in there out. The more restricted your muffler is, the more time that it takes for it to clear out, the more time the exhaust port needs to be open to give it time to clear out. And the more blowdown you need so that it doesn't go shooting down the transfer ports, your exhaust, your spent fuel charge. So again, if you look at, we talk about terms of vacuum and whatever, but it's high pressure and low pressure, vacuum and compression, or high pressure, low pressure, right? It's really where we got to talk about what terms makes the most sense. If the first 50% of the port on the intake produces 90% of the air going into the intake, and that same thing applies to the exhaust. And the exhaust has to be nearly fully expelled by the time the transfer is open. So if you look at blowdown in that way, your blowdown is enough time for that exhaust to get out before the transfers have to start pushing in. And a lot of people think that there is a tremendous amount of pressure in the crankcase to push that charge up through to the top, overcome that exhaust. But there's not. It's around 7 to 10 pounds of pressure in the crankcase. Otherwise, you'd blow the seals right out of the saw. Right off the crankshaft. So the exhaust is gone out in the degrees of blowdown, and the higher the RPM is, the more blowdown you need, and the higher the RPM, the more transfer you need, area, and the more blowdown you need, and at some point you have to raise your exhaust. If all that made sense to you. So these are all the things I gotta consider every time I look at a motor, and I map it out for port timing and stuff, and I take it apart and then I study. What am I looking at, right? And this is brand new. I cut the base and the squish, and then are my numbers after that. So I have to consider how much I can take out of the transfers. 1, without grinding through. 2, how much can I widen without short-circuiting everything? And how much exhaust duration do I need to make it all work together? So you can only get as much in the motor as that you can get out. We can put I don't know, what do you want to put on it? You want to put an 850 Alley on there? You're only going to get as much in the motor as this carburetor can feed, or the crankcase volume can handle. And how much is transferred in each revolution. Everything has its limitations here of how much you can get through it. And the higher the RPM, the more time that each port needs to do its job. So that's where we get into port time area. It's the amount of time in the amount of area that you have to get the job done. And I know I get into all this terminology, but you have to understand that before you can understand what you're doing. If I took this cylinder and I just said, okay, I'm going to make that intake port bigger because, it ain't big enough, and I just start grinding away on it, and I grind it out bigger than the boot here, so it doesn't match here, what good have I done? What have I gained? If I make this hole a great big huge hole, and left this alone, what have I gained? You know, you're only going to gain anything on your duration, which is on the floor. And I could sit here for 3 hours trying to think of how to explain this stuff. And it's quite difficult because, you know, a lot of guys just don't quite understand the science. You know, we can talk theory all day long. Big hole flows more. That's theory. But that's not necessarily correct. We can theorize on things all day long, but until we put them into practice, we don't know. And believe me, I have ground intakes out. I've done everything you can imagine to these saws over the years. I've been at this for, it's going on 40 years. And, you know, if it could be tried, I'd probably tried it. And I'm still learning. You know, every once in a while a cylinder fools me and I learn something. And you don't know unless you try. And it's not fun anymore once you stop learning. So open-minded people are the easiest for me to talk to. People who are stuck with whatever they're doing make it very difficult for me to explain things. But this is a work saw, not a race saw. I'm not building a race saw. I'm working with what I have here. And I'm also considering fuel mileage in my build because it matters. You know, we're trying to build a working production saw. And if you're sitting at the gas can every 10 minutes filling up with gas, you're not getting any production done. So fuel mileage matters. I look at fuel mileage a couple different ways, but in any case, it does matter, and it matters to me. It matters to my logger customers, and that's all into consideration. If I'm building a play thing, we don't really consider mileage because it doesn't matter. If I'm building an all-out race saw, it ain't even a thought. We don't care what we're wasting. But you can't make power out of fuel that you threw out the muffler. So, and I don't know, you know, I see this tonsil thing, guys doing this tonsil thing. Wow, I dropped you guys. Sorry. And they think that it improves the flow. One guy in particular, and I don't like doing names, pulled it off from the idea off from a dirt bike. And unknowingly, he doesn't understand that that tonsil is down in there as a ring support. That's all it was there for. And on that particular application, it was the biggest hole that they needed, that size hole. And I put a little tonsil in there for ring support. 028 steel comes to mind, has the same thing. And it's only in there for ring support. It's not in there for a performance reason. The hole needs to be that big, and something has to support the ring because it gets down that far, and that's what it's there for. And something else somebody can try to explain to me. I watched a video the other day of this. The guy said that when the piston starts to close the intake, that you shouldn't be able to see the ring in the exhaust port. And he said it wouldn't make a good motor if the ring showed. I would really, truly like somebody to come up with a logical explanation as to why that would make a difference. Because I absolutely can't. I've been thinking about it for a few days. And that logically makes no sense to me whatsoever. Anyways, that's probably it for this one. I'm going to get to work on this. I will probably set this video up and our camera up here. I might talk a little bit, but I'm just going to start porting next video. And if you guys just want to watch what I'm doing, you can just watch what I'm doing. It's not going to be very exciting. But it's a video, I guess. And maybe I will record most of what I do through this saw. And we'll do a little video series or something. So, till the next one.